Hello and welcome to another interesting video of a new series I started. It's called Packet Trace Analysis, basically malware analysis, packet trace analysis. I'm gonna use some Wireshark now, and basically I'm gonna try and go more into the part where we are responding to an attack. And today I'm gonna try and respond to a brute force attack. So I'm gonna generate the traffic with you guys right now using Hydra. This is just some web form that I decided to use. The web form is on TryHackMe. It's basically this web page here, and it doesn't really matter what it is because this is just any web page. And what I'm gonna do is go ahead and start Wireshark basically, and we should basically see a lot of TCP traffic already happening. So what I'm gonna do is I'm gonna try and see if this is gonna work. So I will go back here, and we can see that Hydra is running. It's gonna guess the password, send 41 requests. I'm gonna stop the traffic and filter it on HTTP first of all, and basically we can see the traffic that I sent here with the protocol. So first of all, let's just verify that what I did here was correct, and I can see that I used Hydra, which is a beautiful tool to brute force our way through to a login form, for example, on a web page. So we can see that I diverted my traffic to this local IP address on my VPN that I'm connected to. It's a HTTP post form, and basically it's gonna be directed to a /login, which we can see here. It is /login, and I'm gonna replace username and password and stuff. I'm gonna use the word list called RockU, and this is just 41 attempts, and we have a hit here with sunshine just to show you that it works. So we just did a direct brute force. Is the actual completion of this room, but the actual completion of the room is not really the point. The point is the packet trace. So I'm gonna close some things down here, and we're gonna 100% just verify everything we can see here on Wireshark. I'm gonna try and let me just see preferences, fonts and colors. Gonna make this a bit larger. Let me just choose, I think 14 would probably be okay for your eyes. Oh, that's a bit big, I assume. So it's bold, just ridiculous. Thank you. Yeah, this is gonna be it. So let's continue and look at the trace. So let's take a look at what we have here. I already put a filter down here on the HTTP traffic, and we can see that well, I want to say we can see it's like 16 packets we see sent to login at like more or less the same time. So what this basically means is that if you go back here to the actual command, I'm going to try and pair this. We can see that it does actually send 16 tasks per iteration, cyclist, whatever they call it. So it is expected that we send 16 login requests, and then we're gonna get somewhat 16 HTTP OKs back, one after another. So it's gonna be around looking that way, but it's not. You could have a different trace. Sometimes you get like login first, and you get the data and so on. But in this particular case here, it's all just smashed together in a way, and basically it's gonna be the packets we will look at, and there's quite a few packets. So let's look at the very first packet we got here. You know, we are sitting in the security operations center right now, looking at this trace. You know, we're looking at this, you know, file. Someone sent it to us, or anyways, and we're looking at it basically. So it's gonna be a bit different when it's live traffic, because then you have logs files continuously being appended to and stuff like that. But in this case, we are handed in like we're trying to learn how it looks like. So the very first where is it? The very first packet here sent is the we can see that it's coming from. I should say that the IP address 10.11.0.2.1 is my local IP address in this machine, and the machine I'm communicating to is called 10.10.61.119, which is the machine here on TryHackMe that I started up. So you can see that I'm verifying to right now that although the time is ticking, that the server is actually running. This is an actual IP address on the local network that I'm using. So we can see that it's a TCP protocol, and we can see the port and everything, but the interesting part is the HTTP protocol here. And we can see that I'm requesting the login page, and what we could do is to right click here and say follow HTTP stream, and then we can basically see the stream that is, you know, a part of the actual exchange of data from Hydra and the web page. So what we can see here is that I sent a GET request to the server requesting the login page, and I'm getting a HTTP 200 OK back basically, and we can see the Hydra request itself is as simple as it can be. So already now I see the usage in this Hydra, so I could already now say, okay, this is a brute force attack. So we can see that we're getting back from the server. It's an actual request, a response, sorry, saying 200 OK, and we're getting the HTML that is, you know, the actual login form. We can see it's saying body class center, form sign in, you know, we have the input fields and stuff like that. And we can verify that by looking at the page here. And this is the actual, you know, it's the exact same HTML we see here that we see on the Wireshark trace. So that is the actual, you know, this isn't nothing bad here going on, you know, it's just the first request, but yeah. So we can also see in the top here that we do have the typical SYN, ACK, you know, TCP connection handshake. So we actually creating a connection. We do have some sort of, you know, packet being sent here. We can see it contains some data, which is this form here. So I do from, let's see, let me just see, we have this there, and there we have our requests, and then we get a response back, and let me just see. What I'm looking for here is the post. I think we're not there yet, so I'm gonna go back to the HTTP request and filter out. And what you see down here is the actual post requests. Now, because this is, you know, highly grouped in larger sections, it's very difficult to, you know, understand the flow of it. So basically you should think that you're sending a GET request to the web server requesting the login page, you're getting a HTTP 200 back, and then you are sending the form data via a post request using the HTTP protocol. That's going to be the first one we see here. Let's see, this is one, so let's right click and say follow your HTTP stream, And here we can see that we are actually sending the data from my machine to the host. I mean the destination, sorry. And we can also see that it's sending the right here. Since this is only HTTP, it's clear text. In the case of a TLS certificate present, also commonly known as SSL certificates or HTTPS secure or encrypted, traffic on a browser, this would be not readable unless we were having the certificate. So anyways, we can see that it's sending this data here. We are using Hydra still as a use agent. We are giving the container length. We're saying now it's application stuff data we're sending. And then we send the username Molly. And the very first try of the password is 123456. If we go back to the Hydra call here of the brute force, we can see that the very first attack is with the password Molly. The login username Molly and the password 123456. That is the very first request that we sent, which we can also see right here. So this is basically it, and it's saying found redirecting to login, and that's about it in this request here. So let's go back and filter again, and the actual responses for all these. So we can see that we are sending, and this can be quite difficult to know which one it is. So let's see. This is the request. Wireshark is helping us a bit here, so it's saying this is the one we're requesting, and then we are sending here again some data. So we can try, and this is also not really interesting, but this is just basically the found redirecting we're looking at, so it might look interesting. Sorry. So we are sending more codes, and we do get something back at some point. So let's look at this. Let me just see. We should look at. So maybe we should try and just write 123456 and press enter. And basically what happens is that we're getting this username or password is incorrect. So what we could do is to see that we're getting some kickback from the server. This is the one, and it's saying line based redirecting to login, which is not the one we're interested in. It should be this one here, so I'm double clicking. Let's just see. Maybe I should right click and say follow HTTP stream, and let me just see. You can see that it says here your username or password is incorrect. So this is the response we're getting from just see from the server we're trying to brute force on, and we can see that it's an HTTP version 1.1 200 OK. Now usually when you see that, you might think, okay, so I just don't click the right place. There you go. Usually when you see that, you might think this is okay because it says 200 OK, which is a successful interaction with the web server. It's the HTTP protocol saying back everything is fine. You request a resource that is present on my server, so you can actually get a response back. So basically it's that easy to miss when you look through logs. So what we do see here is a big collection of data where we just have a lot of the same chunks of get this login again and then send some post data, getting a little more mixed in the long run, because at some point, we do have a lot of threads running, but maybe getting too technical on threads here, but if we're sending 16 at the time, and I do not have 16, well, I do actually have 20 cores on my machine, but I didn't give this virtual machine 16 cores, but let's just assume 16 is the number, and just one more time, it says here, it says max 16 tasks per one server, so that is 16 tasks per try, and basically in the start you will see like it's more block orientated, so 16 first and 16 responses, but then in the end it will mix in a little more, because the server will get some lag time, response time, and it will mix in a little more. That's why you see 3 here and 1 here. So that is very typical to see, and this is where you would very benefit from the filters on Wireshark. So if I should see the actual login request, I would definitely look for the post requests here. So what you're gonna do is you're gonna go to Google and say Hydra, and then filter post requests, and then basically you will get some sort of, I should probably write HTTP in front. So this wasn't the page. Let's just see. No, Wireshark, sorry. I'm a little tired today, so it's how to do post request only. So basically just take this there and go back to Wireshark. That's about it. And then you say, okay, I want to see all the post requests, and then you look at it and say, wow, I have like what is it, 41 requests. And if we look back on the actual attack, we notice that I did 41 attacks. So everything is here, as you can see. It's not hidden or anything. I'm trying to show you both sides of the case. So I'm the attacker, but I'm also the analyst behind it all, saying, oh, we did have an attack here, we have a breach, because I can see that the very last one here, say follow HTTP stream, this is where it is not directly attached to the, so I'm gonna take, the way of doing it is scrolling as much as I can to the bottom, and the very last post request I see is this one here, and I see I'm getting a response there, and it will seem this is the one, follow speed stream. I'm still having incorrect, so that is not the one. It's very difficult to see, but I do know when you actually log in, it's gonna say Molly Sunshine. It's gonna say something like this. So I could take, just for simplicity's sake, in Hydra say that Wireshark. I couldn't Wireshark say, where was all my windows? I'm gonna look for string, so I could press Control F, string, and then put that in, and I should basically get it as this one here should be, if I am not mistaken. Maybe I'm mistaken. That is not the right one. Very difficult to view on this color here, so no packet contained that. I'll just try one more time. Okay, so let's do HTTP one more time. Yeah, just try that. Okay, so it's very difficult to find the thing that I'm looking for. It's especially because it's something that is far down. But one of these do contain the actual flag or whatever they call it, and I would say the way you could find out whether you compromised or not, you know, the long run would probably be to look through these log files. So, but I'm really just, you know, trying to prove a point here that you could do it, and it's just a lot of traffic to look through, but I think we're getting there. Could also be JavaScript, and then of course I could not see it here because this is not executing JavaScript at all. But I highly suspect it is not JavaScript. It would be pretty stupid for a small web page. So let me see, it's also incorrect, so I guess at some point we're gonna find the right one, but it is of course getting a bit tiring to just look at these, you know. It is not really, we already know that we broke it and it is broken, but you know, it would be fun to just see the actual result. I don't know where it is, to be honest. It's there somewhere, the request, not the incorrect. Which one it is, I'm not really sure, but it is there for sure. And this is how a brute force attack would look like if you are looking at the traffic from a, you know, security operations perspective. This is exactly what you're gonna see, and this is exactly what you should suspect. So this is the way to see it. This is just HTTP. I'm gonna do other protocols as well. You know, I'm gonna try SSH probably, FTP protocol, and basically go through the same thing again, and then we can learn more as we go. How does traffic look like in real life, so we can learn more. Take care until next time.